All right, let's take a look here. Whoa, holy crap. Okay, that'll work out. So how did you guys do the first one here?
Multiply the top and bottom.
Yeah, now the funny thing is you could do 20, 2 would work too, because then it would be 6/10, so you can make that a decimal and then you move it over. So there's multiple. But if you do it by 20, then that works for both of these, right? Because that would be 60 over 100. So what percent is that?
60.
60%. So what is that as a decimal?
0.60.
0.60. Yeah. I like it.
Why should I have that by 20?
Because that's the way to make the bottom 100.
Oh.
What'd you do?
I divided it. I saw the
Oh, yeah.
same thing,
Yeah,
but
totally. So long division will always work.
that's easier.
Because that's what a fraction is division. But in the special case, where the bottom can become 10 or 100, of course I'm going to do that. Because then the decimal's easy. If the bottom's 100, the percent is sitting there staring me in the face.
What if we just put 0.6?
Oh yeah, that's fine too. I mean, that's the same thing, right? Yes, 0.60 is 0.6. Right? They're the same thing. Now, real quick, we've talked about that before, but what's 0.60 officially? That's tens, hundreds. That's 60 over 100, right? Oops. There you go. And then what happens here? Don't these cancel? And then what's 6/10? 0.6. So of course these are the same, right? The little zeros after the last number in a decimal are unnecessary. They're just, I can make it 0.6 if it's cents. 0.60, then it's like 60 cents. I can see that. But 0.6 is the same mathematical number. They're the same number. They represent the same amount. In fact, they both represent 60%. Maybe. Now, the more you do this, the more you'll see when to do which kind of thing and what's the easiest thing to do. Right now, you just got to get used to all the different ways to do things. So on this next one, where can I go from here?
To the left.
Yeah, so I can move it once, twice, back. And then the fraction is easy. Tenths, hundredths, thousands, 427 over 1,000. Now you could also make this. Is that cool? Now for some of you guys, if you wanted to, you can do 42.7 over 100, but you have to clean that up, right? Don't stop there. Bless you. Because again, that's like fracception. That's a decimal inside of a fraction. So you got to move this over once, you get the same damn answer we just got. So these, I don't know if I better say this just in case I need to. Every column is the same number. That number is the same as that number, is the same as that number. They are all the same number, they're just different representations. So how do I write the number 2? 8 over 4 is another way to write the number 2. Do you understand what I mean when I say that? That's what 8 over 4 represents, the number 2. 2.00 is also 2, right?
So if I wrote 4,270 over 10,000, it'd be wrong.
I mean, you're not wrong. It's just you went one more zero than you needed to. I'm not sure why you went there.
I don't know either.
I think because you added the 2 decimals over.
I wouldn't take points off, but I would probably put a little note like, why? All right, what about this one? Where can I go from here? Either way actually is easy, right? Hopefully, or relatively easy. How do I go from this to a percent? Which way? All right, so 1, 2. So it'll be 6.4%. And again, just to reinforce what I said earlier, see how that number, 6.4, is bigger than the decimal one. So the percent number will always be bigger than the decimal number. Yeah. Oh, I'm hoping you guys stretch. So what about, how do I get to a fraction? It's just going to be
2 numbers.
tenths, hundredths, thousands. So 64 thousandths. You could do a similar thing with 6.4 over 100. Then you have to move it over once, so it'll become over 1,000. It's always got to agree with itself, no matter which way you went.
You could do it that way also. Like for 60, you get to see like 10, 100, and
for the 6 and 0, right? Like, you know the 60 right there? You could just see it as tens, and then hundreds with the 0, right? And then it would be 60 out of 100.
Oh yeah, you could have done that up here too. Is that what you're saying?
Yeah.
Yeah. Well, the first one there, we already knew the
Yeah,
fraction.
but like, it wasn't there.
Yeah, I got you. What about this one here? How do I make that into a decimal?
You move it to the
Move it back, yeah. So once, and then the 0 becomes visible twice. So 1, 2, 3, 0. So 0.1233. So another way to think about it, how many zeros are currently right in front of the 3? 1. When I move it back twice, there's 2 more, now there's 3. So it's always moving it twice. And then what place am I in? Tens, hundreds, thousands, 10,000s. And again, if you did this, it was 0.03%. So that's 0.03 over 100. Again, if you don't like this way, don't do it this way. But if you move this over twice, you got to move this over twice. 3 over 10,000, same answer we just got. It's got to be. Yes, sir.
I'm confused. Why are you moving it to the left?
Which one? All right. Alan, help me out. What do we do here? Did you have any trouble with this one? No, right? Because what's the process say? If you start at a percentage, how do you make it a decimal? You move the decimal place twice back. You got to separate the number you're seeing from the process. The process doesn't give a shit what the number is. 42.7, that's nice. Move it back twice. 0.03, that's nice. Move it back twice. That's how I make a percentage become a decimal. So don't let the 0.03 tell you what to do. The fact that it's a percentage tells you what to do. I got to move it back to make it a decimal. Period. Right? It's sort of like, I had this really silly example come to mind. How do I use a napkin? Well, if you're eating soup and you get some soup, you wipe it off. Well, what if I'm eating barbecue? All right, wait, you wipe it off. What if I'm eating a corn on the cob? You wipe. I don't know if you understand. The process of cleaning your mouth doesn't care what food you ate, right? How do you use a napkin? You're not going to do it. Do you understand what I know it's a silly example, but there's a process about how to change from a percentage to a decimal. It doesn't change because it's a different number there, right? The number doesn't tell me what to do. The idea of what percentage is tells me what to do.
We're eating chicken.
I love you. All right. Well then, I don't know, you just got to take a bath. So what about this guy? Which way? There's multiple answers you get here. How do I make that into a percentage?
Move it to the right.
112.
Move it to the right. Once, twice. 112%, yeah. And now this can either be, what's that one say? 112 over 100. Or this is 1 and 1200s. Either way. No thousands there anywhere. Nobody's in the thousands place. Is that cool? What's up?
I kind of have a question. So, if it's out of 100 and it's more than 100,
Yeah.
like if you have.
Oh, okay. No, you ready? All right, now watch. So what I was saying earlier is, if you have if I have 8 apples, and you have 100% of the apples that I have, that means you also have 8 apples. So what if you have 12 apples? Then you have more than 100% of what I've got. You understand? So a percentage by itself could definitely be more than 100%. If I double what I made last year, then I made 100% more. I made 200% of what I made last year. If I doubled. Now, if I'm talking about probabilities that can also be written as percentages, they can only go up to 100%. You can't say there's a 200% chance of rain tomorrow. What the hell does that mean? Is that going to be like monster rain? Like, boom, you know? I don't know what 200% would mean. It's so going to rain. It's going to rain from all directions at once. So with the probability that uses percentages, they have their own restrictions. That doesn't mean that percentages have any restrictions themselves, right?
I think I had that same problem, because like, I was thinking of like, how you're saying like the watermelon thing, like.
Yeah, exactly. But, you know, if I had a watermelon and a half, well, how many watermelons? I got like 150% because I got like extra watermelon. If I need one watermelon and I get one watermelon and a half, I got 150% of what I needed.
Right.
Does that make sense?
Yeah, it does.
So percentages themselves all day long can be bigger than 100. Cool? But in certain situations, it makes sense that 100 would be the biggest it could be, right? Okay. Maybe. Oh, what was I about to do? Shit. Somebody asked me a question. I went off on a tangent or something.
About being over 100% you're going to show.
I was. And I forgot what I was going to do. Does that make sense? Is there still a question about that?
It does.
I was going to do something here and then I forgot. Okay. Okay. So how do I do this one? I can't do it the same way I did the first one. But some of you guys did the first one a different way. That worked anyways. And of course, I have to do it here. So if I can't make the bottom become 100 or 10 or some 10, I have to do what this says to do, which is divide. I have to do that. So I have to do 16 into 3.000. So what do you guys get? You get 1, 16, 14, 8, 128, 120, 7. See, 112, you get 80, 5. Okay. So again, I'm going to desperately try to remember on the test to either tell you to round it to a certain number of places or give you problems where it will actually stop somewhere, right? So where do I put this? Good, that's the decimal. That's the actual number. 3/16 is the same as 0.1875. They're the same number. Now how do I make that into a percentage?
0.
Move it to the right twice.
Once, twice, 18.75%. So kind of hopefully it makes sense. One something is 100% of that thing. So if I have a part of something, it's going to be some percentage less than 100%. So 20% of something is 20 out of 100, 2 out of 10, 1/5 of that thing. So 20% of something is the same as 1/5 of that thing because they represent the same number. Okay, it's a little weird, but I know, but we'll get deeper into that later. I don't know why I like doing this left-handed thing so much, but I put another one in. 20 people, 3 left-handed people. What percentage are left-handed?
15%.
How'd you get there?
3 over 20.
3 people out of
20.
20. And if you do, so I can just multiply this by
5.
11. So 15 out of 100, so 15%. Kick ass. Anytime you can make the bottom 100, a hell yes. Because then the top is the percentage answer. You're done. Kicks ass. What's the matter? Is that too bad to say kicks ass? Said ass. All right. So just a little bit of this, I think, and then I'll let you guys get out of here.